Right now, as you lie here listening, roughly 15% of the people alive on this planet are walking around with something in their blood that should not, by any reasonable measure of evolutionary logic, exist. Something that scientists, after more than 80 years of careful study, still cannot fully explain. It is called Rh-negative blood, and it is one of the most quietly persistent mysteries in all of human biology. Here is what makes it genuinely strange. Every primate on Earth carries the rhesus protein on the surface of their red blood cells. Chimpanzees have it. Gorillas have it. Orangutans have it. Every species of monkey that researchers have ever examined carries this protein. It is universal across our entire evolutionary family, and which makes it all the more remarkable that roughly 15% of human beings simply do not have it. They are Rh-negative, and no one has yet been able to say with certainty why. You might be tempted to shrug that off. People lack certain proteins all the time. Genetic variation is ordinary. Bodies differ from one another in 1,000 small ways. But this is not like having blue eyes instead of brown. This is not a cosmetic difference or a minor quirk. This is something that reaches into the fundamental mechanics of how a human body functions. It affects pregnancy. It affects which blood transfusions a person can safely receive. It affects whether a mother's own immune system will treat her unborn child as an invader. These are not small consequences. And then there is the distribution pattern, which is where the real strangeness begins. In most of the world, Rh-negative blood is quite rare. In large populations across Asia, Africa, and the pre-Columbian Americas, it is nearly absent, sometimes registering below 1%. But among one specific group of people, the Basque population of northern Spain and southern France, it reaches frequencies approaching 30%, nearly 1 in 3 people. That is not the fingerprint of random genetic drift. That is the signature of something that happened in our past and that we do not yet understand. The Rh factor itself was only identified in 1940. But the moment researchers grasped what they were looking at, they understood they had found something that did not behave the way evolution was supposed to behave. But traits do not simply vanish from entire branches of the primate family tree and then reappear as a missing feature in a subset of one species, unless something specific and powerful drove that outcome. For 80 years, scientists have been trying to reconstruct what that something was. If you are using this to carry yourself toward sleep, that is exactly the reason these videos exist. Perhaps subscribe, and if you feel like it, leave a note in the comments telling us where you are and what time it is there. I do read them, and what always strikes me is the reach. Someone in Tokyo just before dawn. Someone in London at the edge of midnight. Someone in Los Angeles settling in for the night. All of them drifting through the same mystery together. The theories surrounding Rh-negative blood cover an extraordinary range. And some researchers have pointed toward ancient population bottlenecks and the genetic drift that occurs when small groups become isolated for long periods. Others have raised the possibility of Neanderthal ancestry, of genetic mixing between our species and our closest extinct relatives. There are theories involving prehistoric plagues, about survival advantages that protected certain populations while others perished. And then there are the theories that venture into far stranger territory. Ideas about ancient genetic manipulation, about bloodlines that predate recorded civilization, about the Nephilim described in early religious texts, about contact with beings whose origin was not terrestrial. Before you dismiss those last ones, consider one detail that even the most cautious scientists acknowledge. Rh-negative mothers, due to when carrying Rh-positive babies, can develop an immune reaction that treats the fetus as a foreign body. The mother's own biology turns against her own child. This condition, known as hemolytic disease of the newborn, killed countless infants throughout history before medicine found a way to prevent it. Think about what that means from an evolutionary standpoint. Natural selection is ruthless about eliminating anything that reduces reproductive success. So why would a genetic trait persist across millennia, across population after population that actively works against successful childbirth? It does not follow the rules. Unless Rh-negative blood arrived under circumstances where the ordinary rules did not apply, or unless it carried some compensating advantage significant enough to offset the cost. Royal families across Europe spent centuries fixated on the purity of their bloodlines. They called it blue blood. They arranged marriages within narrow circles of carefully selected dynasties. They believed something ran through their veins that set them apart from common people. Whether they knew it or not, they may have been concentrating specific genetic traits through those choices, including, researchers later found, unusually high rates of Rh-negative blood. Coincidence? Possibly. But certain bloodlines also suffered from hemophilia at rates that are statistically improbable. Queen Victoria's descendants spread a bleeding disorder across every major royal house in Europe, and many of those same families showed elevated Rh-negative frequencies. Over the next few hours, we are going to follow this mystery wherever it leads. We will trace Rh-negative blood back through history, through ancient civilizations and medieval dynasties and modern genetic research. We will look at the pregnancy paradox in detail, at the geographic distribution and what it suggests, at the theories both scientifically grounded and spectacularly ungrounded. We will examine the claimed differences in physiology and psychology, the alleged advantages, and the strange correlations that keep reappearing in the data. Something happened in our past. Something that left 15% of all living humans with blood that evolution should not have allowed to persist. The story of how we got here is stranger than it first appears. Vienna, 1937. Karl Landsteiner was already one of the most celebrated scientists alive, and he had won the Nobel Prize 6 years earlier for identifying the ABO blood group system, solving one of the deepest practical mysteries in medicine. For decades, physicians had known that blood transfusions sometimes saved lives and sometimes killed patients within minutes, with no reliable way to predict which outcome would follow. Landsteiner had found the reason. But now, working at the Rockefeller Institute in New York with his colleague Alexander Wiener, he was about to discover something that would make his earlier work look straightforward. They were not looking for a new blood type. The experiments they were running were standard immunology work, injecting blood from rhesus macaque monkeys into rabbits and guinea pigs to observe the immune responses. Routine, and the kind of work that produces predictable entries in laboratory notebooks. Except the results were not predictable. When they tested the antibodies produced by the rabbits against samples of human blood, something unexpected happened. The antibodies triggered a reaction in approximately 85% of the samples, causing red blood cells to clump together in the distinctive pattern that signals an immune response. But 15% of the samples produced no reaction at all. Nothing. As if those blood cells were simply invisible to the antibodies. This should not have been possible. The antibodies were responding to a specific protein on the surface of most human red blood cells. And a significant minority of people simply did not carry that protein. They were missing something that nearly everyone else possessed. Landsteiner named it the Rh factor, after the rhesus monkeys whose blood had helped reveal it. Carrying the protein meant you were Rh positive. Lacking it made you Rh negative. A clean binary classification for what would turn out to be a much more complicated biological puzzle. The protein itself was not unusual in any general sense. Virtually all mammals carried some version of it. Dogs had it. Earlier mammalian ancestors had carried related proteins. It was not some exotic feature of primate biology. It was fundamental, which made its absence in 15% of humans all the more confounding. The early research turned quickly to practical questions. What did this mean for medicine? And the answers emerged fast and badly from obstetrics wards across Europe and America. Physicians had known for years about a mysterious and devastating condition in newborns. Babies, particularly second and third children, were sometimes born severely anemic, their bodies swollen, their skin yellowed with jaundice. Many died within hours. Others survived, but with permanent brain damage from the buildup of bilirubin in their circulation. The pattern was consistent and inexplicable. First children were generally healthy. Second pregnancies sometimes brought problems. By the third or fourth pregnancy, the risk had become genuinely terrifying. Something about the experience of pregnancy itself appeared to be teaching mothers' immune systems to attack their own babies. But no one could identify the mechanism. The connection to the Rh factor came through a pediatrician named Philip Levine. In 1939, just 2 years after Landsteiner's discovery, Levine was treating a woman who had delivered a stillborn baby. When they attempted to give her a blood transfusion to replace what she had lost during the delivery, her body rejected the blood of her own husband. They shared the same ABO blood type. This rejection made no sense. Levine tested for the newly identified Rh factor. The woman was Rh negative. Her husband was Rh positive. And suddenly, the mechanism became visible. During pregnancy, small amounts of fetal blood can cross into the mother's circulation, most often at the moment of delivery when the placenta separates from the uterine wall. If the mother is Rh negative and the baby has inherited the father's Rh positive blood, the mother's immune system encounters a protein it has never encountered before and does not recognize as belonging to her body. It responds as immune systems are designed to respond. It mounts a defense. It produces antibodies. The first pregnancy usually proceeds safely because that immune response takes time to develop fully. But once those antibodies exist, they remain. They circulate. And if the next pregnancy produces another Rh-positive baby, those antibodies are small enough to cross the placenta and they begin attacking the fetal blood cells, labeling them as foreign invaders. The body that evolution had shaped over millions of years to protect and nurture offspring was being turned against them. This was unprecedented in human genetics. Other species had immune incompatibilities of various kinds, but nothing quite like this. See, nothing where a second child faced systematically greater danger than the first simply because of a blood protein. The medical response was relatively swift. By the 1940s, Doctors had developed exchange transfusion techniques that could replace an affected newborn's entire blood volume, removing the maternal antibodies before they caused fatal damage. It was brutal and dangerous, but it saved lives. Later came Rh immune globulin, an injection given to Rh-negative mothers after delivery that prevented them from ever developing those antibodies in the first place. The problem was solved, medically speaking, but the scientific questions were only beginning. Landsteiner died in 1943, just 6 years after his discovery. He never lived to see how deep the mystery ran. Just because, as researchers began systematically testing populations around the world, what they found made no evolutionary sense at all. Rh-negative blood was not evenly distributed. It clustered. The Basque people showed frequencies as high as 35%. Other European populations ranged between 15 and 25%. But across Asia, Africa, Australia, and among indigenous populations of the Americas, Rh-negative blood was vanishingly rare. In some populations, it appeared to be entirely absent. This geographic pattern suggested something profound. The Rh-negative trait was not ancient in the way most fundamental human biology is ancient. It did not appear to be something our species had carried since its origins in Africa, but it looked like something that had emerged in one specific population and then spread through parts of Europe while remaining absent elsewhere. But when had it appeared? And why? Genetic mutations are ordinary. But mutations that eliminate a fundamental protein do not usually persist in large numbers. They certainly do not reach frequencies of 15 or 20 or 35%. Natural selection should have acted against any trait that caused mothers' immune systems to turn on their own children, unless that trait provided some other advantage, something substantial enough to outweigh the reproductive cost. Something that allowed Rh-negative individuals not merely to survive, but, in some populations, to thrive. In laboratory discussions and medical conferences throughout the 1940s and 1950s, researchers began circling a question that seemed deceptively simple, but opened into extraordinary complexity. Where had Rh-negative blood come from? Some suggested it was a straightforward loss-of-function mutation, a random deletion of the gene that produces the Rh protein. Just one of those things that happens in evolution. But that explanation did not account for the geographic clustering or the high frequencies in specific populations. Others raised the possibility that it might offer protection against some disease, perhaps one that was prevalent in ancient Europe but rare elsewhere. But no clear pathogen connection emerged, and a few, very quietly, began suggesting something else. What if Rh-negative was not a mutation at all? What if it was ancestral? A retention of something from an earlier phase of human variation, preserved in isolated groups, while disappearing from the broader population. The discovery had revealed an anomaly, and that anomaly was pointing toward something larger than anyone had yet begun to look for. So, you have learned that Rh-negative blood is rare. You have learned that it creates medical complications that should not exist if human evolution followed any simple or linear path. Now comes the part that is genuinely strange, the geographic distribution. Because Rh-negative blood does not scatter randomly across the human population. It follows a pattern, a specific, precise, and deeply puzzling pattern that raises more questions than it resolves. Begin with the epicenter, the place where Rh-negative blood reaches its highest known concentration anywhere on Earth. A mountainous region sitting between Spain and France, the home to a people who have confounded researchers for over a century, the Basque Country. Among the Basque people, between 30 and 35% of individuals carry Rh-negative blood. Read that again. Roughly 1 in 3 Basque people. That is not a rare mutation. That is a defining characteristic of the population. To place this in context, the global average sits at about 15%. In most of Europe, the frequency hovers between 15 and 18%. In Africa, Asia, and the Americas among indigenous populations, it falls to 1% or less, sometimes effectively 0. But among the Basque, it is 1 in 3. You might attribute this to statistical chance, small isolated population, founder effect, genetic drift, the usual mechanisms that explain unusual frequencies in enclosed gene pools. And perhaps that is all it is. Except that the Basque are not only unusual for their blood, they are unusual for nearly everything about them. Start with language. Euskara, as they call it, resembles nothing else on Earth. It is not Spanish. It is not French. It bears no relationship to any Indo-European language, and it bears no relationship to any language family that linguists have ever been able to identify. It stands alone, an island of linguistic isolation surrounded by the ocean of Indo-European languages that swept across Europe thousands of years ago, replacing nearly every indigenous tongue in their path. Everyone, apparently, except Euskara. Linguists have spent more than a century attempting to classify it. They have compared it to Caucasian languages, to ancient Iberian tongues, to North African dialects. Nothing fits. It is as though the Basque preserved something from a time before the Great Migrations that reshaped the linguistic landscape of the continent. Before Indo-European speakers arrived with bronze weapons and horses and conquest, the Basque were already there, speaking something no one else could understand. And they are still there, still speaking Euskara, still carrying Rh-negative blood at rates that resist easy explanation. This is a pattern: genetic isolation paired with linguistic isolation. A people who remained distinct while wave after wave of migration washed across Europe around them. But it deepens further. The Basque are not the only population with elevated Rh-negative frequencies. They are simply the most extreme example. When you map Rh-negative blood across Europe, a clear gradient appears, and beginning in the Pyrenees and spreading outward. Move west from the Basque Country through the rest of Spain and Portugal, and the frequency drops slightly, but remains high by global standards. Move north into France, especially Brittany and Normandy, and similar patterns emerge. These are the Celtic regions, the Atlantic fringe, the parts of Europe that absorbed less of the great eastern migrations. Continue north to Ireland and Scotland, and the pattern persists. The Irish show Rh-negative frequencies around 25%. The Scots, especially in the Highlands and Islands, similar numbers. Wales, roughly the same. All the Celtic populations, all the Atlantic coastal communities, all showing elevated frequencies. Then move east. Travel from the Atlantic coast toward Central and Eastern Europe, and the frequency drops. So not dramatically, not all at once, but steadily. Germany around 15%. Poland similar. Further into Russia, falling to 8 or 10% in some regions. South into the Mediterranean, moderate frequencies. Further east into Turkey and the Middle East, lower still. Into India and China, below 5% among indigenous populations. Africa tells an even more striking story. In most of sub-Saharan Africa, Rh-negative blood is extraordinarily rare. In some populations, effectively absent. The pre-Columbian Americas show the same. Among indigenous populations without European ancestry, Rh-negative blood is virtually non-existent. It arrived with European colonizers and mixed into populations that had never known it. The conventional explanation offered by mainstream genetics is migration and mixing. Rh-negative emerged as a mutation in one population, probably in Europe, became established there before later migrations diluted it, and the geographic gradient reflects the movement of Indo-European populations westward from the Pontic steppe around 5,000 years ago. In the West, where those migrations had less impact, the older European genetic heritage was better preserved. The Atlantic populations are the relics, survivors of a genetic pattern that once covered more of Europe before incoming populations from the East changed the landscape. This explanation works. It is internally consistent. It requires no exotic theories, just population genetics unfolding over thousands of years. But it leaves questions standing. Why would this specific mutation become so common in Western Europe? Blood-type mutations typically remain rare unless they offer some selective advantage. What advantage could possibly have driven Rh-negative blood to 30% frequency among the Basque? Why would natural selection allow a trait that creates potentially lethal complications during pregnancy to persist and even flourish? And why does it appear so rarely in Africa? Humans evolved in Africa. Hundreds of thousands of years passed there before our species expanded into Europe and Asia. If Rh-negative were simply a random mutation, you would expect to find it distributed more broadly. But it is virtually absent from the continent where our species spent most of its existence. Then there is the Berber connection. In North Africa, among the Berber populations of Morocco and Algeria, researchers have found something unexpected: in elevated Rh-negative frequencies. Not as high as the Basque, but higher than surrounding populations. The Berbers also speak a language that does not fit neatly into the dominant language families of the region. They have cultural traditions suggesting roots in North Africa that predate the Arab conquest by millennia. Some researchers have noted genetic markers connecting Berber and Basque populations. Not recent connections, not evidence of close historical mixing, but deep ancestral markers suggesting both populations preserve elements of ancient groups that once occupied larger territories. Similar patterns appear in other isolated mountain communities. The Caucasus Mountains, home to dozens of ethnic groups speaking dozens of languages. The Atlas Mountains of North Africa, the Scottish Highlands, the Pyrenees. Both these mountain refuges seem to preserve genetic patterns that vanished from surrounding lowlands. Mountains protect, they isolate. Migrations flow around them rather than through them. New populations settle the accessible valleys and plains. The mountain communities remain, generation after generation, holding older genetic and cultural patterns in place. This suggests something significant. Rh-negative blood may not be a recent mutation at all. It may represent a genetic signature from populations that inhabited Europe and North Africa before the agricultural revolutions, before Indo-European expansion, before the genetic landscape of Eurasia was transformed by 10,000 years of large-scale movement. The Basque may be special not because they developed Rh-negative blood, but because they preserved it. They may be a genetic museum, displaying traits that once covered a much wider territory before being diluted or lost. A window into ancient Europe. But that raises another question. If Rh negative blood is genuinely ancient, what environmental pressures would have maintained it at such high frequencies? What were our ancestors facing 15 or 20,000 years ago that made this trait advantageous enough to reach 30% in some populations? Europe during the last glacial maximum was a severe landscape. Small populations fighting to hold on in a world dominated by cold and scarcity. Under those conditions, even a modest survival advantage could drive a genetic variant to high frequencies quickly. Small population plus strong selection produces rapid genetic change. Maybe Rh negative provided some advantage we have not yet identified. Now maybe it was simple genetic drift in small isolated communities. Or maybe there is something else. Some piece of the puzzle we have not yet found. Because the map does not only show us where Rh negative blood exists, it shows us where it survived. And what survives in the isolated places sometimes tells you something important about what once existed everywhere. Now here is where the story takes a different turn. While scientists were mapping Rh negative blood across populations and puzzling over its geographic patterns, someone else began noticing something. The crowned heads of Europe, those carefully maintained bloodlines that had ruled for centuries, carried a secret of their own, and it was written in their blood. The phrase blue blood did not emerge from nothing. In Spanish, y sangre azul originally described the pale-skinned Castilian nobility whose veins appeared blue through their skin, supposedly demonstrating they had not interbred with darker-complexioned Moors. But the deeper obsession with blood purity among European royalty went far beyond skin tone. They believed something essential flowed through their veins, something that distinguished them from common people, something that justified their claim to rule. They may have been more correct than they realized, though not in the way they intended. When researchers began systematically examining blood types in royal families during the 20th century, they found something unexpected. Rh negative blood appeared with unusual frequency among European nobility. Not universal, not even a majority, but statistically notable. The Romanovs, the Windsors, and various branches of Spanish and French royalty all showed higher rates of Rh negative blood than the general populations they ruled. Before drawing any sweeping conclusions from this, a clear distinction needs to be made. The presence of Rh negative blood in royal families does not suggest that Rh negative people are naturally suited for leadership. It does not imply anything inherently superior about that blood type. What it does reflect is the mathematical consequence of centuries of deliberate inbreeding. A small population marrying exclusively within itself will concentrate whatever genetic traits it carries, beneficial and harmful alike, through simple probability. But the consequences of that concentration tell us something important about biology, and about what happens when any group becomes too insular for too long. A Queen Victoria is the clearest illustration. Born in 1819, she became the most powerful monarch in the world, ruling an empire that covered a quarter of the globe. She had 9 children and placed them strategically into every significant royal house in Europe. And without knowing it, she distributed a genetic time bomb through that web of dynasties. Victoria carried hemophilia B, a disorder that prevents proper blood clotting. The gene sits on the X chromosome, meaning women can carry it without showing the disease themselves, but their sons face a 50% chance of inheriting the full condition. For someone with hemophilia in the 19th century, even a minor injury could become fatal. There was no treatment, no cure, only constant vigilance and the persistent terror of bleeding to death from wounds that a healthy person would barely notice. Victoria passed the gene to at least 3 of her children. Her son, Leopold, died from hemophilia at 30 after a minor fall. 2 daughters, Alice and Beatrice, became carriers and passed it further. Alice's daughter Alexandra married Tsar Nicholas II and gave birth to Alexei, heir to the Russian throne. Alexei's hemophilia rewrote history, not through the disease itself, but through the desperation it created. Nicholas and Alexandra, watching their only son endure constant bleeding episodes, became consumed by the search for relief. They found Grigory Rasputin, a Siberian mystic who appeared able to ease the boy's suffering, likely through calming techniques that reduced stress-related bleeding. Rasputin's growing influence over the royal family became a scandal during the First World War. While Nicholas commanded the army, Alexandra leaned on Rasputin's counsel, even in political matters. The Russian aristocracy watched a peasant mystic effectively controlling access to the throne. His presence became a symbol of royal dysfunction and decay. When he was assassinated in 1916, the damage was already done. The revolution swept through Russia within months. Nicholas abdicated. The family was imprisoned. In July 1918, in a basement in Yekaterinburg, every member of the family was executed. Alexei was 13 years old. The Spanish Habsburgs offer an even more extreme case. Generations of cousin marriage had left Charles II, who inherited the throne in 1665, with an inbreeding coefficient of 0.254. For reference, values above 0.25 are generally considered incompatible with viability in animal breeding programs. Charles suffered from severe jaw deformity that made eating and speaking difficult, was reportedly sterile, experienced epilepsy, and was likely intellectually disabled. He died at 38, without heirs. His death triggered the War of Spanish Succession, which killed hundreds of thousands across Europe. This was not hemophilia. This was the accumulated weight of multiple recessive disorders, expressing simultaneously because the family tree had stopped being a tree and had become something closer to a tightly knotted loop. The Rh-negative connection to these dynasties is not that it caused their downfall. It is that these families were concentrating all of their genetic traits simultaneously, including blood type. And if early royal ancestors happened to be Rh-negative and their descendants kept marrying within the same narrow circle, the frequency of Rh-negative blood would naturally increase generation by generation. Some researchers have suggested that Rh incompatibility may have contributed to the staggering rates of infant mortality in royal households. Before modern medicine, an Rh-negative mother carrying a succession of Rh-positive babies would have faced compounding risk with each pregnancy. Royal records document miscarriages, stillbirths, and infants who died within days at rates that were elevated even compared to their equally privileged peers. How much of that was Rh incompatibility versus general inbreeding depression versus ordinary historical child mortality is impossible to calculate cleanly. But the possibility that the very blood these families glorified as proof of their superiority was also quietly undermining their dynasty carries a particular irony. The genuine lesson embedded in the history of royal bloodlines runs directly counter to the mystique those bloodlines cultivated. It is not that concentrated heritage creates strength, it is that genetic isolation, even among the most privileged humans in recorded history, generates vulnerability. The Habsburg jaw, the hemophilia spreading through Victoria's descendants, the cascading infant deaths. These were not signs of special blood. They were warnings, written in genetics, that diversity is not a dilution of something valuable. It is the mechanism by which living things remain viable. The royals feared nothing more than the mixing of their blood with common people, and that fear, expressed faithfully across centuries, produced exactly the kind of biological fragility they had tried to guard against. So where did Rh-negative blood actually come from? This blood type carried by 15% of the global population, but reaching 40% in some isolated communities. This genetic marker that does not distribute randomly, that creates complications during pregnancy, that clusters in specific populations in ways that standard evolutionary models struggle to explain fully. The mainstream answer is mutation and drift, a random deletion in the RHD gene that produces the Rh protein, occurring in one individual at some point tens of thousands of years ago, gradually spreading through certain populations while remaining rare or absent elsewhere. No exotic explanation required. So just normal genetics operating over long time scales. But that answer has never entirely satisfied the people who study this closely. Because the distribution is not random, and the clustering demands explanation. The most scientifically credible starting point is the Cro-Magnon hypothesis. Around 45,000 years ago, anatomically modern humans entered Europe. We call them Cro-Magnons, though that label simply refers to the first modern humans known from the European archaeological record. They were not Neanderthals. Neanderthals had occupied Europe for over 200,000 years, perfectly adapted to the Ice Age conditions of the continent. They were physically powerful, culturally sophisticated, and successful on their own terms. These new arrivals were different, and they came from Africa and the Middle East carrying advanced stone tools, complex hunting strategies, art, music, and symbolic thinking. When they arrived, Europe was already occupied. The two species coexisted for thousands of years. We know this because the archaeology confirms it. Sites of both species existing side by side within miles of one another. We also know they interbred. Genetic analysis has settled this beyond serious dispute. Modern Europeans carry between 1 and 4% Neanderthal DNA. Mixing occurred multiple times in multiple places across thousands of years. Some researchers have suggested that Rh-negative blood may be one of the genetic legacies of that ancient interbreeding. It's a marker that emerged in those early European populations either from Neanderthal genes or from the distinctive selective pressures that Cro-Magnons faced while adapting to European environments. The evidence is circumstantial but intriguing. Rh-negative reaches its peak in the Basque region, areas that genetic studies have repeatedly identified as among the most anciently rooted in Europe, with the lowest levels of mixing from subsequent migrations. If Rh-negative emerged in those first modern European populations, the Basque might carry it at high frequencies simply because they remained relatively isolated for tens of thousands of years. But the Cro-Magnon hypothesis does not resolve everything. It still does not explain why a trait that creates pregnancy complications would be preserved at high frequencies through natural selection, which opens the door to theories that venture progressively further from mainstream science. One of the most persistent involves Atlantis. Plato described an advanced civilization that was destroyed catastrophically around 11,000 years ago. Most historians regard Atlantis as philosophical allegory or embellished legend, but theorists have connected it to Rh-negative blood by proposing that survivors of that destruction dispersed to various coastal and mountainous regions, including the Basque Country, Ireland, and parts of North Africa, carrying their genetics with them into the populations they joined. The geographic distribution of Rh-negative blood in this reading maps the diaspora of Atlantean survivors. There is no archaeological evidence supporting this. No sunken city, no genetic signature traceable to a single catastrophic dispersal. But the theory persists because it offers something the mainstream explanation does not: a narrative. A story that makes the anomaly feel meaningful rather than accidental. Then there is the ancient astronaut theory. This one moves well beyond the boundaries of conventional speculation. The premise is that at some point in human prehistory, extraterrestrial beings visited Earth and interbred with humans. The offspring of those unions carried genetic markers distinguishing them from purely terrestrial humans. Rh-negative blood, in this framework, is one of those markers. Proponents point to ancient texts describing beings who descended from the sky and mated with human women. They point to the unusual properties of Rh-negative blood, the pregnancy paradox, to the geographic clustering, the claimed physiological differences. They ask why evolution would produce a blood type that works against reproduction unless it was not produced by evolution at all, unless it was introduced from outside. Mainstream science dismisses this completely. There is no physical evidence of ancient extraterrestrial contact. The pregnancy complications can be explained through normal evolutionary mechanisms. The distribution patterns match what population genetics would predict. But dismissal has not ended the conversation. These ideas remain active in alternative research communities. More grounded, though still contested, are the biblical interpretations. The book of Genesis describes the Nephilim as the offspring of the sons of God and the daughters of men. The passage is brief and open to multiple readings. Some researchers have connected the Nephilim to royal bloodlines, to the divine right of kings, to the elite dynasties of ancient civilizations that practiced strict intermarriage, supposedly to preserve sacred genetics. The biblical account continues with the flood, a catastrophe that destroys the Nephilim and most of humanity. But some survived. Were those survivors carriers of Rh-negative blood? Is that why it appears in populations descended from the Mediterranean and Middle Eastern regions, where these events are said to have occurred? Mainstream scholars see this as reading far more into the text than the text supports. The Nephilim account is brief, cryptic, and open to interpretation that does not require connecting it to any specific genetic trait. But the mystery remains. Why does Rh-negative blood cluster with unusual consistency in populations that carry deep mythological traditions of divine ancestry? The mutation theory offers the cleanest explanation. Somewhere between 35 and 40,000 years ago, in some human population in Europe or the Middle East, a genetic mutation occurred. The RHD gene that normally codes for the Rh antigen on red blood cells was deleted or inactivated in one individual. That person became the first Rh-negative human. The mutation was passed to their children. In a small, relatively isolated population, genetic drift could push the frequency higher through chance alone. Over thousands of years and multiple migrations, the mutation spread through certain groups while remaining rare in others. Modern genetic research supports this general picture. We can trace the RHD deletion back tens of thousands of years. We can watch it spreading through European populations during the Neolithic period. We can map its frequency changes over time as populations moved and mixed and sometimes remained isolated. Everything fits standard population genetics models. No ancient civilizations, no extraterrestrial intervention, no divine bloodlines required. But even mainstream researchers acknowledge the puzzles that remain. Why has natural selection allowed Rh-negative to persist at such high frequencies despite the pregnancy complications? Are there hidden advantages still undiscovered? Some studies have suggested slightly different immune responses, possible resistance to certain diseases, perhaps subtle neurological differences. The evidence remains preliminary, contested, and difficult to replicate consistently. And there is the psychological dimension. Across decades of research, anecdotal reports keep surfacing. Rh-negative individuals describing themselves as feeling different, experiencing unusual sensitivities, claiming perceptions that others do not share. Science classifies these reports as confirmation bias, as the human tendency to find patterns in noise. But they persist, generation after generation, culture after culture, creating a folklore around Rh-negative blood that science struggles to either fully explain or fully dismiss. The truth probably lives somewhere between the extraordinary theories and the standard mutation explanation. Human genetics is messy. Our evolutionary history is complicated. And sometimes the most compelling questions are not the ones we can answer definitively, but the ones that keep us searching, keep us asking where we came from and what we carry without knowing it. Here is where the story goes dark. Here is where evolution appears to have made an error so fundamental that it should have corrected itself long ago. Because, under specific circumstances, an Rh-negative mother's immune system could destroy her own unborn baby. The mechanism is precise and devastating. A woman with Rh-negative blood, it does not matter which ABO type, as long as she lacks that Rh protein on her red cells, becomes pregnant by an Rh-positive partner. Since 85% of people are Rh-positive, this is statistically the most likely scenario. If the baby inherits the father's Rh-positive blood, you have an Rh-negative mother carrying an Rh-positive child. For the first pregnancy, things usually proceed safely. The placenta does a remarkable job keeping maternal and fetal blood circuits separate. Two circulation systems running side by side, exchanging oxygen and nutrients through cellular barriers without their blood actually mixing. Usually. But at delivery, those barriers fail. The placenta separates from the uterine wall. Small amounts of fetal blood cross into the mother's circulation. For the first time, her immune system encounters the Rh protein on her baby's red blood cells, recognizes it as foreign, and does precisely what immune systems evolved to do. It builds a defense. It produces antibodies. The first baby is generally born healthy. The immune response takes time to fully develop. But once those antibodies exist, they do not disappear. They circulate, waiting. And when the next pregnancy brings another Rh-positive baby, those antibodies cross the placenta and begin attacking the fetal red blood cells from inside the womb. The medical term is hemolytic disease of the newborn. The plain translation is that the mother's body is destroying her baby's blood while the baby is still developing. The baby compensates by producing red blood cells at an accelerating rate, trying to replace the ones being destroyed. But the destruction outpaces replacement. The baby becomes profoundly anemic. The heart enlarges and strains to deliver oxygen with a depleted supply of functional red cells. Fluid accumulates in the body cavities. The liver and spleen swell as they work past capacity. In severe cases, babies arrived swollen, barely alive, pale and laboring. Many died within hours. Others survived with permanent neurological damage from oxygen deprivation during critical developmental windows. Some mothers watched baby after baby die without ever understanding what was happening inside their own bodies. Before 1968, physicians could only observe. They understood the mechanism by then. They could identify which pregnancies were at risk, but they could not prevent the sensitization, could not stop the immune memory once it formed. The grief this produced is almost beyond calculation. Imagine a woman in the early 20th century who delivers a healthy first child. Then her second baby dies shortly after birth. The doctors speak of blood incompatibility and immune reactions but offer no solution. She tries again. Another death. And another. Some families lost 5, 6, 7 children in succession, each pregnancy arriving with hope and departing with loss. Each birth dreaded as much as anticipated. From an evolutionary perspective, this is deeply puzzling. This is not a rare condition affecting isolated individuals. Rh incompatibility is common in populations where Rh-negative blood is frequent. It would have affected thousands of pregnancies each generation, and yet the trait persisted. Evolution is ruthless about eliminating features that reduce reproductive success. What greater reduction could there be than a mother's immune system killing her own children? Unless there was an advantage. Something substantial enough to offset the terrible cost generation after generation. Some researchers have proposed that Rh-negative individuals may have enhanced immune responses to specific pathogens, and that the same immune characteristics that cause the pregnancy conflict might make certain infections easier to fight off. There is some evidence for this, though the data remains incomplete. Others have raised the possibility of protection against specific parasites. Toxoplasma gondii, a parasitic infection with serious implications during pregnancy, appears to affect Rh-positive and Rh-negative individuals differently in some studies. Rh-negative individuals may have some enhanced resistance, though the evidence remains mixed. Or perhaps the advantage is not biological in the individual sense, but structural. In small, isolated populations, genetic drift can preserve traits that would otherwise be selected against. If a trait becomes established in a small community by chance, it can persist across many generations as long as its costs are not immediately catastrophic. But before modern medicine, the costs were catastrophic for the affected families. Then came 1968. 2 researchers in New York, Vincent Freda and John Gorman, and a third working independently in Liverpool, William Pollack, developed an intervention that changed everything. They called it Rh immunoglobulin. We know it now as RhoGAM. The principle was elegantly simple. If you could prevent the mother's immune system from ever recognizing the Rh-positive fetal blood during that first delivery, she would never develop the antibody memory. No sensitization, no antibodies, no danger to subsequent pregnancies. RhoGAM works by delivering preformed antibodies against the Rh protein to the mother shortly after she delivers an Rh-positive baby. These introduced antibodies quickly bind to any fetal blood cells that entered her circulation during delivery, coating and clearing them before her own immune system can identify and memorize the foreign protein. The threat is neutralized before the body has time to build its own response. The impact was immediate. Within a decade, deaths from hemolytic disease of the newborn dropped by more than 90% in countries where RhoGAM became standard care. Families that would otherwise have suffered repeated infant losses could now have as many healthy children as they chose. Today, the protocol is routine. Every pregnant woman has her blood type checked. If she is Rh negative and the father is Rh positive or unknown, she receives RhoGAM at 28 weeks and again after delivery if the baby is confirmed Rh positive. Additional doses follow any event that might cause fetal blood to cross into the maternal circulation. It has become so unremarkable that most people who receive it barely register it. A brief appointment, a single injection, a few minutes. But those minutes represent one of medicine's most complete victories over a biological problem that had plagued our species potentially since the Rh-negative trait first appeared. Every generation, every century, every millennium between that first appearance and 1968, mothers were losing babies to this invisible war between blood types. They attributed the losses to luck, to divine will, to curses, to weakness. They had no way of knowing that the cause was written in a single protein, present or absent on the surface of a red blood cell. And yet, despite all of that loss, Rh-negative blood survived. It persisted. It was passed forward. Which brings the central mystery back. What advantage could have offset such a devastating cost? What benefit could have made all of that suffering worth preserving? We do not know with certainty. Perhaps we never will. But the fact that Rh-negative blood is still here, still common in certain populations, still flowing through millions of people alive right now, suggests that somewhere in our deep evolutionary past, it provided something valuable. Or perhaps the answer is sadder than that. Perhaps there was no advantage. Perhaps it is simply a neutral trait that became established by chance in a small, ancient population and persisted from there. And thousands upon thousands of families paid the price of that accident across the centuries. Either way, thanks to RhoGAM, that particular suffering has largely ended. The pregnancy paradox has been resolved, at least where modern medicine is accessible. The trait remains. The questions it raises about human evolution and migration and survival continue to occupy researchers today. And now we arrive at the part of the story that keeps the topic alive in late-night searches and quiet conversations. Not chromosomes or antibodies or evolutionary pressures. Superpowers. The moment people understood that roughly 15% of humans were missing a protein that essentially all other primates carry, the imagination began filling in the space that science left open. And over time, a collection of claimed traits attached itself to Rh-negative blood and has circulated ever since. lower body temperature, heightened intuition, unusual eye colors, sensitivity to light, resistance to certain illnesses, psychic perception. One by one, these claims accumulated, building a folklore around a blood type that science has never quite managed to fully dislodge. Let us walk through them carefully, not to dismiss them without consideration and not to accept them without scrutiny, but to identify where evidence ends and where storytelling begins. The first cluster of claims is physical. Lower blood pressure, lower resting body temperature, heightened sensitivity to pain, unusual reactions to heat or cold, a particular vulnerability to bright sunlight. Some Rh-negative individuals describe feeling overwhelmed in direct sunlight, as though their skin and eyes amplify rather than filter it. Others describe being consistently the coldest person in any room, or the one who faints most easily in heat. In online communities, these shared reports accumulate into patterns, and patterns become narratives. Before long, the story has solidified. Rh-negative people are physically different, more sensitive in some ways, more finely attuned in others. There is a kernel of measurable reality in some of this. A small number of studies have found that on average, Rh-negative individuals may have slightly lower blood pressure than Rh-positive individuals. The differences are modest. Not all studies agree, but the observation is not entirely invented. Light sensitivity is more complicated. Many people who describe themselves as sensitive to sun and light also happen to be fair-skinned with lighter-colored eyes. As these traits cluster in the same Northern and Western European populations where Rh-negative blood is most common. Blue or green eyes, pale skin, and Rh-negative blood can travel together in these populations, not because the blood type causes the other traits, but because they all arise from the same ancestral gene pool. The connection is statistical. The interpretation of causation requires more care. That brings us to one of the most persistent features of Rh-negative identity claims: unusual eye color. In forums and online communities, the refrain recurs like a quiet rhythm. Hazel eyes, green eyes, eyes that shift color with mood or light or health. Stories of eyes that do not fit any standard category. For some, this becomes more than pigmentation. It becomes visible proof that the blood marks them as different. Genetically, eye color is determined by multiple genes, many of which are prevalent in the same European and North African populations that carry high Rh-negative frequencies. The statistical link between Rh-negative status and lighter mixed eye colors exists in some populations, but it is a consequence of shared ancestry, not of the Rh antigen itself. Still, when your eyes look unusual in the mirror, and you already know your blood type is rare, it is difficult not to weave those observations into a single story. Then there is intelligence. Many Rh-negative individuals report being told from early childhood that they think differently or learn unusually fast. Small studies, sometimes misrepresented or taken out of their original context, have been cited as evidence of higher average IQ among Rh-negative individuals. This idea is powerful and appealing. It suggests that your blood type carries within it a cognitive advantage, a sharpness of mind that is part of your inheritance. But when researchers look carefully at large populations, controlling for education, socioeconomic background, and region, the alleged gap largely disappears. Any differences found are small, inconsistent, and rarely rise above statistical noise. Intelligence is shaped by an enormous range of factors: genes, nutrition, childhood environment, schooling, health, and elements that are essentially random. There is no robust scientific evidence that the presence or absence of a single antigen on red blood cells produces meaningful differences in cognitive ability. And yet, the idea persists, not because it has been demonstrated rigorously, but because it speaks to a feeling many arch-negative individuals already carry, that they think and feel differently from most people, and they are searching for an explanation. Health claims extend further still. Some people insist that Rh-negative blood provides resistance to specific viruses or parasites. Claims circulate that Rh-negative individuals rarely contract HIV, that they are less vulnerable to malaria or toxoplasmosis or certain respiratory infections. The reality here is genuinely nuanced. There is evidence that different blood groups, including the ABO system and the Rh factor, can influence susceptibility to certain diseases in specific ways. Some ABO types have been linked to varying risks of certain cancers or cardiovascular conditions. Rh status has been studied in relation to Toxoplasma gondii, with some findings suggesting Rh-negative and Rh-positive individuals may show different behavioral and physiological patterns of response to infection. But these findings are narrow and tentative. They do not translate into sweeping immunity from entire categories of disease. Rh-negative individuals still contract colds. They still develop serious illness. They still end up in waiting rooms and hospital wards alongside everyone else. The distance between a subtle statistical difference observable in a laboratory and the claim of resistance to whole classes of disease is significant. Much of what circulates online belongs on the wrong side of that distance. From here, the claims move away from biology entirely. The body temperature myth suggests that Rh-negative individuals run colder, almost reptilian in their thermal profile, and some theories tie this to proposed non-human ancestry, blending conspiracy frameworks with popular imagery until the original idea is barely recognizable. In actual physiology, human body temperature varies across a modest range based on stress, hormones, time of day, and health status. Some people naturally run slightly warmer or cooler. A few studies have found small differences in thermal comfort zones between Rh-positive and Rh-negative individuals, but nothing that constitutes a separate category of organism. The reptilian framing does not come from measurement. It comes from the symbolic language of the cultural theories that produced it, in which reptiles carry connotations of coldness, mystery, and alien origin. It is less a biological observation than a story being told. And once the door to the otherworldly opens, other claims follow: psychic sensitivity, precognition, heightened empathy, a sense of knowing things before they happen, the ability to read a room before entering it. If you listen to enough of these accounts, patterns do emerge. I always knew when something was about to happen. I dream things that later come true. I feel other people's emotions as though they are my own. On their own, these experiences are not specific to Rh-negative people. People of every blood type and every culture have reported intuitions, vivid and seemingly prophetic dreams, and moments of inexplicable knowing. Our brains are pattern detection instruments. They process thousands of impressions daily, most of them below conscious awareness. When a small fraction of those impressions later align with events, the experience can feel genuinely remarkable. Oh, and if you have already been told that your blood is rare, that your body operates on unusual settings, that you belong to a small fraction of humanity with a different inheritance, then every intuitive hit becomes evidence in a case you were already building. What does science actually say about Rh-negative individuals and psychic ability? At present, nothing solid. No controlled, replicable studies have demonstrated enhanced extrasensory perception linked to Rh status. What has been more consistently documented is that individuals who already hold belief in paranormal phenomena are more likely to interpret ambiguous experiences as supernatural, more likely to seek confirming information, more likely to join communities that share their interpretive framework, and more likely to notice patterns that fit their existing expectations. This does not mean their experiences are fabricated. It means we do not have evidence that an antigen on the surface of red blood cells is controlling them. So why do these ideas persist? Why are they compelling enough to survive decades of scientific dismissal? Part of the answer lies not in biology, but in the psychology of identity. Being Rh-negative places you in a group comprising roughly 15% of the global population, and far less in some regions. Rarity confers meaning. When something about you is uncommon, the question of why has real pull. In a world where traditional sources of belonging, village, religion, extended family have often weakened, a biological marker can feel like something solid and permanent. This is in my blood. This is what I am. Blood-type identity frameworks, whether Japan's ABO personality system or Rh-negative superpower communities in the West, offer simple narratives in a world that rarely offers simple anything. They tell you who you are. They explain why you have always felt slightly out of step. They place you within a lineage and give that lineage significance. The risk emerges when the metaphor solidifies into dogma, when blood type is used to limit what someone can do or who they can love, when health decisions are made based on rumor rather than evidence, when a rare genetic variant is used to establish hierarchy between groups of people who all share the same fundamental humanity. The challenge is to hold two things at once: recognition that some correlations involving blood type and health are real, even if small, and the commitment not to leap from correlation to cosmic significance, from interesting pattern to predetermined destiny. Science is not finished with blood. Large-scale genetic studies continue to find subtle links between blood factors and disease risk, immune function, and physiology. As tools improve, researchers may identify effects that were too small for earlier methods to detect. Ancient DNA extraction is pushing further into the past, recovering genetic information from bones tens of thousands of years old. We may one day be able to watch Rh-negative variants emerge and spread across prehistoric landscapes in close to real time. We may identify the selective pressure that allowed them to persist at such high frequencies in certain populations. Or we may discover that no single clear advantage ever existed. That what we are looking at is the accumulated result of chance operating in small, isolated communities across very long timescales. When someone says that being Rh-negative means they are more intuitive, or more sensitive, or simply more something, there are two ways to receive that. You can take it as a claim about literal blood-encoded superpowers waiting for scientific confirmation, or you can hear it as a description of lived experience, of a lifelong sense of difference, of a search for an explanation that feels commensurate with how unusual it is to move through the world the way that person moves through it. In the quiet and dimly lit space of late night, it can be strangely comforting to imagine that your blood carries echoes of ancient lineages and forgotten migrations, and that something in your veins connects you to a history that stretches back much further than your own life. Some of that may be literally true in ways we do not yet fully understand. Some of it may be poetry rather than genetics. Either way, the red cells moving through your body right now are doing something undeniably extraordinary. They are keeping you alive, feeding your brain, sustaining your heart, connecting you through an unbroken chain of descent to ancestors who survived plagues and famines and ice ages and childbirths in eras when survival was far from guaranteed. Whether your Rh factor is positive or negative, that alone is its own kind of superpower, one shared by every human being still breathing tonight. Picture a quiet office in Tokyo, fluorescent lights humming, keyboards clicking, voices low. A perfectly ordinary workday until the manager, during a team-building exercise, asks everyone to write their blood type on a name tag. Nobody finds this strange. For a significant portion of Japanese society, that small detail, whether A or B or O or AB, is not merely a medical fact. It is a personality sketch, a suggestion about whether you are methodical or impulsive, reserved or outgoing, a natural team player or a difficult individualist. This is blood type personality theory. According to this framework, Type A people are earnest, organized, conscientious. Type B individuals are creative, independent, sometimes self-centered. Type O personalities are confident and natural leaders. Type AB are complex, private, a blend of contradictions. A complete typology. A zodiac built not from stars, but from antigens and plasma. Walk into a bookstore in Japan, and you will find compatibility guides organized by blood type, diet books, parenting manuals, television segments, analyzing celebrities through the lens of their blood type. Pop idols mention their blood type in interviews the way someone in the West might mention their astrological sign. And here is the fascinating structural detail underneath all of this. The entire system is built almost exclusively around the ABO system. The plus or minus that indicates Rh status barely enters the conversation. To someone in the Western Rh negative communities, where the crucial mystery is always the Rh factor, this can feel almost inverted. Two cultures examining the same substance and choosing entirely different places to locate the meaning. The blood type personality system in Japan traces its origins to early 20th century pseudoscience. A researcher in the 1920s attempted to link blood type to racial character, drawing on ideas that were circulating dangerously across Europe at the same moment. Those theories were discredited after the Second World War, but the underlying concept did not disappear from popular culture. It mutated slowly from political ideology into entertainment, from racial pseudoscience into a light-hearted social shortcut. By the 1970s and 1980s, blood-type personality books became bestsellers. Cartoons, magazines, and talk shows all played with the idea that your blood type could explain your quirks, your compatibility with romantic partners, your lucky days. It was catchy, easy to remember, and harmless enough to bring up in casual conversation. But even playful ideas carry consequences. The Japanese language has a word for blood type discrimination. Burahara, short for blood harassment. It describes the real and documented phenomenon of people being treated differently in professional or social contexts based on their blood type. An employee not given a leadership role because Type B individuals cannot be trusted with details. A child teased at school for behaving in ways associated with a particular type. A hiring manager who prefers Type O candidates for sales positions because they are supposedly natural extroverts. These judgments do not come from ancient wisdom or biological evidence. They come from mid-20th century magazine articles and self-help books. But for the people who encounter them, the effects are entirely real. Japanese government agencies and scientific organizations have issued public statements reminding citizens that there is no scientifically supported basis for blood type personality theory. That a blood type letter on a form tells you only how that person's immune system will behave during a transfusion. Nothing else. Meanwhile, in many Western countries, the conversation about blood and identity takes a narrower and more intense form. Interest does not stop at ABO types. It focuses specifically on Rh-negative status. And here, Rh-negative blood is sometimes framed not as a variant, but as an indicator of something extraordinary. Elevated intuition, deeper empathy, unusual independence of thought, vivid dreams, sensitivity to environmental stimuli, a tendency to feel like an outsider in one's own culture or even one's own family. To scroll through online forums and the lists of attributed traits extend generously, rarely consistent in their specifics, but unified by a common thread. The conviction that Rh-negative blood marks its carrier as different, set apart from the majority, connected to something older or less ordinary. Scientists have studied blood groups and personality extensively, not in search of magic, but because the question of whether a biological marker that influences disease risk might also influence behavioral tendencies through subtle physiological pathways deserves serious inquiry. Hundreds of studies have sought patterns. The results are consistent in one way. There is no robust, reproducible evidence that blood type in any significant way determines personality. Individual studies occasionally find minor correlations, small tendencies in specific groups. But when larger analyses combine the data, the signals dissolve into background noise. If blood type influences personality at all, the effect is so small it is overwhelmed by everything else. Culture, upbringing, individual experience, circumstance. Professional organizations in psychology and medicine in Japan have stated publicly that blood type personality theory lacks scientific support. It lives in culture. It is a story we tell about ourselves, rather than a fact encoded in ourselves. Yet both traditions persist. The ABO personality typology in the East and the Rh-negative mystique in the West. Both continue because humans are drawn to categories. For hundreds of thousands of years, survival depended on rapid and accurate pattern recognition. Safe or dangerous, friend or stranger, and edible or poisonous. That instinct expanded as social groups grew. We needed ways to quickly assess people we did not know personally. Over time, those shortcuts took many forms: clothing, tattoos, clan names, astrological signs, personality typologies. In the modern world, they can be anything: your Myers-Briggs type, your Hogwarts house, your blood type. Blood type fits neatly into this ancient instinct because it is invisible and yet labeled. One letter, one plus or minus sign, a fragment of molecular biology that can be inflated into an entire portrait of a person. It gives us something we consistently crave. Identity. If you are type A in Japan, you can read descriptions of your supposed traits and feel seen, even though those descriptions are broad enough to apply to almost anyone. If you are Rh negative in the West, you can find articles about the rare blood of an ancient lineage and feel a recognition that is both comforting and slightly thrilling, even if the specifics are deliberately vague. Psychologists have a name for this tendency: the Barnum effect, the habit of finding highly personal meaning in descriptions that are actually general enough to apply broadly. You are sometimes shy but capable of warmth when you feel safe. You care about people, but sometimes wish they understood you better. You are creative and deep, but often feel misunderstood. Vague enough to fit almost anyone. Specific enough to feel tailored. Blood-type personality systems are built on this effect. They are identity vehicles that feel personal while being universal. And for Rh-negative individuals, the additional dimension of rarity amplifies the effect. Most people in the world are Rh positive. Being negative places you in the minority. And minorities, if offered a narrative that reframes their difference as significance rather than simply anomaly, tend to receive that narrative with some warmth. Instead of your rarity is random and means nothing, the story becomes your rarity connects you to something larger. From a scientific standpoint, Rh negative is one variant among many. A quirk of genetics tied to a protein on red blood cells. It has real and important medical implications, particularly around pregnancy and transfusion. But no confirmed link to intelligence, empathy, or spiritual capacity has been established. And yet on a psychological level, it can function as a quiet, private club. A way of locating yourself in a shared story. A way of saying there are others like me. And our difference matters. It is easy to dismiss these beliefs. But look more carefully, and they reveal something deeply human. Underneath the pseudoscience and the sensational claims lies a universal desire to find coherence in complexity, to locate oneself within a story larger than a single life, to feel that what flows in our veins does not merely keep us alive, but connects us to something. In Japan, that something might be a shared cultural game, a playful mechanism for social bonding. In Rh-negative communities in the West, it might be a sense of threading through history, carrying forward something ancient and quiet and difficult to name. In both cases, science stands nearby and reminds us that the molecules in your blood do not dictate your kindness or your cruelty, your courage or your fear, your destiny or your limitations. But the stories you tell about that blood, those can shape how you see yourself, how you move through the world, what you feel entitled to, what you fear, what you carry with pride. And so, when someone says, "That explains so much about you," referencing your blood type, you are not only hearing a casual remark, you are hearing an echo of something much older. The ancient human habit of taking the complicated and unpredictable reality of a person and filing it into a category that feels clean and manageable. Useful sometimes, harmful sometimes, comforting often. Because, in the end, whatever your blood type, it carries the same essential story. A chain of ancestors who endured and adapted and passed life forward, drop by fragile drop. And that story, the one written in survival rather than in stereotypes, is far more astonishing than any personality chart. Jump now from Ice Age river valleys and extinct human cousins to something entirely modern. Fluorescent hospital lights, plastic tubing, the urgent, precise choreography of an emergency room at 3 in the morning. A paramedic pushes through the doors with a patient on a stretcher. Serious accident. Massive blood loss. The clock is moving in seconds. Before anyone knows this person's name, before their medical history, before anything about their story, the team needs one piece of information. What blood can we safely put into their veins right now? This is where Rh-negative blood steps out of the shadows of genetic mystery and becomes something else entirely. A lifeline. In crisis situations, there is no time for a full laboratory cross-match. You need a blood type that will almost never trigger a catastrophic immune reaction in an unknown recipient. For decades, that blood has been O-negative. In most hospitals, if you walk into the blood bank, one shelf is treated with particular care, labeled clearly, counted carefully, dispensed with reluctance. That is the O-negative supply, the emergency reserve, the option reached for when everything else is too uncertain. Because in the high-speed logic of trauma medicine, O-negative is the closest thing available to a truly universal option. The blood that can go into almost anyone without causing the immune reaction that would make a desperate situation fatal. But the reality of blood compatibility is more complicated than the universal donor label suggests. Human red blood cells carry dozens of antigen systems beyond ABO and Rh. Ekel, Duffy, KID, MNS, and others. Any of these systems can, in theory, trigger an immune response. What made O-negative famous is that on the two biggest and most clinically dangerous systems, the ABO group and the Rhd factor, it presents the lowest possible antigenic footprint. No A antigens, no B antigens, no Rhd antigen. To most immune systems encountering it for the first time under emergency conditions, O-negative appears as the least threatening option. So, when there is no time to determine who the person in front of you really is in the language of blood, doctors reach for the blood that is least likely to be recognized as foreign. Even O-negative is not perfectly universal. Some patients carry antibodies against those smaller, less commonly tested antigen systems. For them, even O-negative can produce reactions. Or this is why, outside of immediate life or death situations, hospitals insist on careful matching. Test, confirm, verify. The quiet, methodical work running in the background while the emergency plays out in the operating room. But in those critical moments, when seconds are the currency of survival, O-negative saves lives over and over. Which is why the people who carry it shoulder a particular kind of medical responsibility, and why there is never quite enough of it. There is a persistent problem woven into the practical management of blood supplies. There is not enough Rh-negative blood. Imagine a city where 15% of the population speaks a rare but essential language. In times of crisis, that language is the only one certain people can comprehend. You would want a large pool of translators constantly available. But in the real logistics of blood banking, those translators are almost always in short supply. Rh-negative blood types make up a small global minority. In some populations, fewer than 5% of people are Rh-negative. And yet those are precisely the units hospitals need to maintain in adequate supply, not only for emergencies, but for every Rh-negative patient who requires transfusion for any reason. Rh-negative individuals cannot safely receive Rh-positive blood without risking sensitization, their immune system building a memory response to the Rhd antigen. This is especially dangerous for women of childbearing age, given what we know about pregnancy incompatibility. So while most patients can receive either positive or negative blood of their own ABO type in a pinch, RH negative patients are confined to a narrower lane. For them, the supply logic is unforgiving. No RH negative donors, no compatible blood. This creates a constant, quiet tension in blood bank management. Hospital blood banks track their RH negative inventory the way a careful navigator watches a fuel gauge over open water. They know how fast it depletes, how long it takes to replenish, and what it would mean to run dry at the wrong moment. Blood donation organizations have developed targeted campaigns to recruit RH-negative donors specifically. Phone calls, reminder messages, the subtle but persistent sense of being permanently on a list that needs you. To be RH-negative in the modern world is to carry a hidden logistical significance. Your blood is not simply one data point in a population. It is a resource that is rationed, planned around, and sometimes urgently requested. But the RH-negative story in medicine is not only about supply and demand. It also touches something more unexpected: possible differences in disease susceptibility. For most of the 20th century, blood groups were understood to matter in transfusions and almost nowhere else. Then researchers started noticing correlations. Type O individuals appeared to have a slightly lower risk of certain clot-related cardiovascular events, but a somewhat higher risk of severe bleeding after trauma. Type A appeared in some studies with elevated rates of certain cancers or heart disease. None of this was simple. None of it constituted destiny. But the patterns kept emerging. The RH factor initially drew less attention in this context. It was primarily a pregnancy issue, a transfusion consideration. But gradually, studies began suggesting that RH status might subtly shift the odds in specific areas. Tentative findings indicated RH-negative individuals might have slightly different risk profiles for some infections, some allergic conditions, some autoimmune patterns. Research into RH status and susceptibility to Toxoplasma gondii infection found possible differences in behavioral and physiological response patterns. Other studies examined links between RH type and mental health traits, or reaction times. The evidence throughout remained incomplete. Then came 2020, and a new virus circled the planet. Hospitals filled not with trauma cases this time, but with patients struggling to breathe. And somewhere in that crisis, researchers turned again to an old question. Does blood type matter here? Early studies, particularly from China and Europe, suggested possible patterns. Type A individuals appeared in some datasets to have a modestly elevated risk of severe disease. Type O appeared to have a slightly reduced risk. Regarding RH status, several analyses suggested being RH negative might be associated with a small reduction in risk of infection or severe outcomes. Not immunity, not protection, just a gentle tilt in probability. As more data accumulated, the picture grew complicated. Some studies supported the association. Others found weaker effects, or none after accounting for age, underlying conditions, and exposure patterns. By late 2021, the scientific consensus was cautious. There might be small correlations between blood type, including RH status, and COVID-19 outcomes. But they were modest at best, dwarfed by factors like age, chronic illness, obesity, and vaccination status. Still, the possibility lingered in public awareness. People searched their blood donor cards at midnight and typed questions into search engines. Am I safer? Am I at higher risk? The honest answer is humbling and reassuring in equal measure. If there is an Rh negative advantage against this particular virus, it is likely small, a nudge rather than a shield. Interesting to researchers and epidemiologists working across large populations. Not decisive for any individual. And yet, from an evolutionary and epidemiological perspective, even small differences multiply. A fraction of a percent across millions of people and multiple generations can bend the arc of history by a degree that is barely perceptible in the moment, but consequential across time. It is possible that in past pandemics, long before any record was kept, certain blood types, including Rh negative, may have fared slightly differently. Those stories are buried with our ancestors, visible only in the survival curves that eventually produced the present. While scientists work through statistical noise looking for faint signals, a different frontier is opening that could eventually reshape the entire conversation. Synthetic blood. Every unit of transfusible blood currently comes from a single source, another human being, screened, tested, typed, and stored in conditions that maintain its viability for a limited time. It is a fragile and perishable system with real vulnerabilities. Natural disasters, armed conflicts, pandemics, and seasonal variations all create shortages. For common blood types, these shortages are manageable. For rare Rh negative variants with unusual combinations of minor antigen patterns, the problem is acute. Occasionally, a patient requires a match so specific that only a handful of compatible donors exist in an entire country. So, researchers have been pursuing alternatives. Some efforts focus on blood substitutes, oxygen-carrying solutions based on hemoglobin compounds, or perfluorocarbon emulsions. Others approach the challenge differently, attempting to grow red blood cells in laboratory conditions. Stem cells coaxed through carefully controlled biological environments into mature red blood cells, identical and standardized, produced in controllable batches. If those cells can be engineered to lack the most common reactive antigens, you approach something close to a genuinely universal red cell. Small-scale human trials of laboratory-grown red blood cells have already taken place, not science fiction. Early and careful and expensive steps. The challenges that remain are enormous. Scale, cost, regulatory approval. The practical transformation of a delicate laboratory process into something that can stock hospital refrigerators worldwide. If this technology succeeds, what does it mean for Rh negative individuals? In one sense, it could relieve chronic pressure on blood supplies. No more shortages. No more emergency calls to rare donors. The logistical significance of Rh negative blood would diminish. But in another sense, the Rh negative story in medicine would not end. Because to build synthetic blood systems capable of serving everyone, scientists need genetic and immunological reference points drawn from real human donors, and including the rare ones. Rh negative blood, with its stripped-down antigen profile, is a valuable template for understanding how to minimize immune reactions, how to design cell surfaces that read as neutral to recipient immune systems. And if researchers ever want to biomanufacture cells carrying extremely rare antigen combinations for patients with complicated transfusion histories, those specifications will be written using the blood of people who carry those traits today. Which returns us to the quiet, practical dimension of the Rh negative condition. The part that involves no ancient mysteries, no cosmic destinies, no hidden superpowers. Simply the question of what you can do right now with the blood you carry. If you are Rh negative, especially O negative, you belong to a small, globally scattered group whose biology is disproportionately valuable to emergency medicine. Each donation you make has an elevated statistical probability of ending up in a trauma situation, a neonatal intensive care unit, an operating room where physicians are working against time. If you register as a regular donor, you become part of a living infrastructure, a quiet, ongoing act of communal survival, a continuation in a strange modern form of those ancient networks of cooperation that carried our ancestors through climate catastrophes and population bottlenecks. Beyond donation, Rh-negative individuals can contribute to medical research. Studies examining blood types and disease risk need enough Rh-negative participants to generate meaningful conclusions. Without them, the data is permanently skewed. Contributing is sometimes as simple as answering a survey. Other times it means a vial of blood and a brief clinic visit, a small investment that feeds into something much larger. Because in the end, the Rh-negative advantage in modern medicine is not a power you feel in your body. It is not accelerated healing or extraordinary perception. It is something quieter and more structural. It is the way your specific antigen pattern fits into the puzzle of human survival, at a moment when we understand that puzzle in molecular detail for the first time in our species' history. It is the role your rare blood plays in emergency protocols and blood bank logistics and laboratories where researchers are trying to grow the future in glass and steel. It is the fact that by simply existing, you carry forward a genetic variation that has threaded through millennia of births and deaths, plagues and famines, migrations and conflicts, to arrive in a world of white coats and centrifuges and softly pulsing monitors. A world where the same invisible markers that may once have shaped survival on a prehistoric landscape now shape survival under the lights of a modern operating room. The Rh-negative mystery began long before hospitals existed, but in modern medicine it has found a new purpose, not as a cosmic anomaly, but as a working resource, a rare material, a bridge between ancient genetics and present-day survival. And even here in the clinical brightness of science, the questions have not stopped. If anything, they have multiplied. Because the more we study this rare blood, the more we ask it to teach us about immunity and disease and human variation across time, the more clearly we see how much remains outside the boundary of what we know. So where does all of this leave us? After a century of blood typing and decades of genetics and thousands of published studies and millions of donated samples, what do we actually know about Rh-negative blood? And what still sits in the dark, just beyond the edge of what our current tools can illuminate? Start with what is not a mystery at all. Rh-negative blood is not evidence of extraterrestrial origin. It is not proof of secret royal hybrids, or subterranean civilizations, or visitors from distant star systems. Genetically, we can see exactly what it is: a missing protein on the surface of red blood cells, a deletion or disruption in the RHD gene. We know what it is, and we still do not fully understand why it spread the way it did, or why its distribution is as sharply concentrated in certain populations as the data shows. That is the first genuine mystery that remains. Why do some isolated groups in Europe show Rh-negative frequencies above 30 or even 40%, while vast regions of Asia and Africa register barely any? Why does this one missing protein draw such a sharp genetic boundary between neighboring populations that have been trading, moving, and intermarrying across thousands of years? Plausible theories exist. Genetic drift amplified in small ancient communities. A disease long since vanished that once made Rh-negative carriers slightly more likely to survive. Environmental factors not yet recognized. But the defining word across all of these is still maybe. Clean. A decisive evidence of the kind scientists prefer does not yet exist. No preserved pathogen to point to. No ancient DNA time series showing Rh-negative frequencies spiking sharply in the aftermath of a specific epidemic. Only hints, patterns, and probabilities pointing in suggestive directions. The second mystery involves timing. We know roughly when the main Rh-negative variants appeared in the human lineage. The genetic evidence converges on a figure in the range of tens of thousands of years, relatively recent on an evolutionary scale, but roughly is doing considerable work in that sentence. We are still missing substantial portions of the timeline. Ancient DNA coverage from across the world remains incomplete, especially from those small valleys and mountain passes where unusual things may have happened to small, isolated populations. We have snapshots rather than a continuous record. And even with full genome sequencing and sophisticated algorithms, researchers are still working through fog. The patterns of Rh-negative lineage clustering can be traced. The spread through certain populations can be reconstructed in broad strokes. But we cannot yet go back far enough to watch the first Rh-negative individual born in prehistory to parents who had no way of knowing their child's blood carried a difference that would eventually generate conspiracy theories and medical breakthroughs in equal measure. The third mystery concerns consequences. The full range of effects that accompany Rh-negative status. For years, people have collected personal observations, patterns in how Rh-negative individuals respond to anesthesia, or how their bodies handle certain temperature ranges, or what their immune systems do in unusual circumstances. Are these patterns real, or are they the noise that always emerges when a group of people are told they share something unusual? Large-scale studies consistently suggest that aside from pregnancy complications and transfusion compatibility, Rh-negative status does not dramatically alter health outcomes for most people in ways that are large and obvious. But Rh-negative is rare. In many populations, the numbers are not large enough to detect subtle effects reliably. A slight shift in immune response under specific conditions, a small difference in susceptibility to a particular pathogen, a variation that only becomes visible under certain environmental pressures. These effects are difficult to capture, so we are left with solid facts surrounded by unexplored shadows. And that is exactly the space where human imagination becomes most active. Rh-negative blood sits at an unusual intersection. It is visible, testable, mapped onto real people's bodies. It shows up in hospital records and ancestry tests and genetic research. It affects real pregnancies and real transfusions and real emergencies. But it is also rare, unevenly distributed, historically tangled up with myths of pure bloodlines and royal dynasties and ancient tribes and secret knowledge. It feels significant. If you are Rh-negative, you may have discovered this not in a textbook, but in a moment of quiet surprise. Sitting in a clinic, being told that your blood could turn against your own unborn child without medical intervention. Or learning that your blood type is among those needed most urgently when time is running out. Those discoveries carve deep emotional grooves, and later, searching online, you may have encountered the strange stories, the claims about psychic abilities, about unusual sensitivity to temperature, about feeling out of place in your own era. Are those patterns real, or is this simply what happens when human beings are told they are unusual and then go looking for evidence? Science, when it is being honest, has to acknowledge it does not know for most of those claims. Testing them properly would require enormous, carefully controlled studies with thousands of participants matched for age, culture, health, and lifestyle. Separating the influence of psychology from the influence of biology. Distinguishing what people observe because they have been told to look from what they would observe regardless. For now, we mostly have stories. Quiet ones told late at night. The woman who says that every time she donates blood, something in her feels briefly right, as though she is doing something her body was shaped to do. The man who grew up in a community where almost everyone around him was arch-positive, and who was told as a child that his blood was rare, and who has never quite shaken the sense of slight distance that created. The mother who lost a pregnancy before Rogam became accessible in her country, and who still experiences her blood as both miraculous and dangerous, simultaneously life-giving and life-threatening. Each story is a single point in a vast and largely unmapped landscape of human experience. And that leads us to the balance we are required to hold. On one side, real mystery. The acknowledgement that we do not yet understand everything, that human biology still has unexplored corners and questions that have not been asked yet. On the other, evidence. The commitment not to leap from "we do not know" to therefore anything is possible and everything might be true. Being intellectually honest means holding both. It means we can say yes, it is genuinely strange that a blood trait that makes pregnancy more dangerous was not eliminated by natural selection, and that strangeness deserves continued scientific investigation. Yes, the geographic pattern of Rh-negative blood is genuinely unusual, especially in regions like the Basque Country, where the genetic history is already unusual in multiple dimensions. Yes, the possibility that Rh status correlates with certain immune responses or disease susceptibilities is worth rigorous study. And simultaneously, we can say no. There is no solid evidence that Rh-negative people are more likely to have psychic abilities or ancient destinies. No proof that any prehistoric civilization was composed exclusively of Rh-negative people, or that ruling classes deliberately bred for Rh status to maintain some occult advantage. No justification for converting one missing protein into a magical explanation for everything that makes a person feel unique. Because in the end, Rh-negative is one note in a vast genetic composition. Your blood type is a tiny fraction of who you are. You carry millions of genetic variants, traces of bottlenecks, migrations, plagues, famines, and forgotten relationships stretching back through time. Your eyes, your brain, your immune responses, your temperament, all shaped by layers of ancestry and experience that extend far beyond a plus or minus sign on a laboratory report. And that may be the genuine lesson at the center of this whole mystery. Rh-negative blood reminds us how irreducibly complex human diversity really is. One small molecular detail, absent on the surface of a red blood cell, generates a story that crosses medicine, anthropology, history, genetics, and mythology. It shapes who can safely receive your blood, how your pregnancies must be monitored, which ancient populations you may be distantly connected to. But it also shows us the edges of our understanding. Even with modern tools, we cannot answer every why. We can trace pathways, map frequencies, build probability models. The deeper logic of evolution often remains half-hidden, like footprints fading into early morning mist. The story is not finished. In the coming decades, as genome sequencing becomes more widespread, as ancient DNA retrieval pushes further into the past, as statistical power to study rare traits grows, some of what is currently mysterious may become clear. We may watch Rh-negative variants appearing and spreading across prehistoric landscapes in something closer to real time. We may identify the selective pressure that maintained them at high frequencies in specific populations. We may find that a particular epidemic, long since vanished, briefly made Rh-negative carriers significantly more likely to survive and reproduce. Or we may find something humbler, that no single major advantage ever existed, that what we are observing is the accumulation of chance events in small communities across very long timescales, that evolution is not always optimizing, that sometimes the story written in our blood is one of brutal necessity, and sometimes it is one of exquisite accident. For now, Rh-negative blood sits between those two possibilities. A real biological anomaly, thoroughly mapped and yet not fully explained. A trait that can complicate pregnancy and yet persists. A marker that connects remote mountain villages, coastal towns, and modern cities in a quiet and invisible kinship reaching back further than any written record. And perhaps that is the thought to carry into sleep. Not that Rh-negative blood makes you more than human, or less, but that it is one more thread in the vast, intricate tapestry of what it means to be human at all. One more reminder that inside each of us, beneath the skin and the stories, the old secrets of our species are still moving, beat by beat, cell by cell, waiting for future generations to read them more clearly. So now, here you are, lying in the dark, breathing slowly, carrying the slow drift of a story that began before there were nations or cities or even names. A story written in something you carry with you every second of your life, your blood. We have moved from ancient population bottlenecks and vanished human cousins to strange antigens and invisible pregnancies, from queens with blue blood to laboratory technicians staring in bewilderment at test tubes that will not behave as expected. From myths of ancient origins to gene variants that quietly tilt the odds against certain diseases. All of it circling one question. What does it mean to carry a blood type that by any simple reading of evolutionary logic should not have survived? The real answer may be this. Rh-negative might feel rare, mysterious, special. But underneath all of those labels, it is still part of the same crimson current that moves through everyone. The same fused chromosomes born in some long-ago crisis. The same ancient survival machinery refined by hundreds of thousands of years of near extinction and slow recovery. Whether your blood is positive or negative, A or B or O or AB, it is a different pattern woven onto the same fundamental fabric. Your heart does not care about theories. It simply continues. Every beat and echo of those first small bands of humans gathered around fires, sharing stories under stars they had not yet named. As every drop carrying the memory of Neanderthals tracking prey through snow, of ancient crossings over land bridges now submerged, of early Homo sapiens following rivers out of Africa. All of it compressed into the quiet pulse in your wrist right now. Some of the deepest mysteries are not out in the universe, written in distant light. Some of them are much closer, inside your veins, in the way one tiny protein on the surface of a red blood cell can determine whether a pregnancy proceeds gently or requires medical intervention, in the way an Rh-negative mother can carry a child whose blood her own body wants to reject, and how a single injection can persuade that body to choose a different response. If nothing else, Rh-negative blood is a reminder that you are not simple. Even if your blood type is the most common in the world, the fact that it functions at all is genuinely extraordinary. Millions of red cells moving in rhythm, hemoglobin picking up oxygen in the lungs and releasing it in the fingertips. Ancient genetic decisions paying off in the quiet miracle of you simply being alive tonight. When this ends, you might not remember the name of every antigen or every researcher, but perhaps you will hold on to this. Your body is full of unsolved questions, small, ordinary, daily miracles that science is still working to understand. You are a walking archive of evolutionary experiments and family stories reaching back hundreds of thousands of years. If you feel curious, you could look up your own blood type if you do not already know it. Ask your parents or grandparents what theirs is. Trace the pattern. See how something as invisible as a protein on a cell connects you to relatives who lived and died before you were born. A quiet family map drawn in red. And if tonight's journey kept your mind gently wandering while you drifted towards sleep, you can support this corner of quiet curiosity in a few simple ways. A tap on the like button, softly, just as a signal that you would welcome more stories like this. A subscription if you want to keep exploring these hidden chapters of history and science and myth while you rest. I would love to know where in the world you are listening from. If you feel awake enough, leave a comment. Your country, your city, or simply listening from bed and your time zone. So there is something quietly remarkable about seeing how many different places are connected by the same story at the same moment through the same small glow of a screen in the dark. For those who want to go a little further in supporting the channel, there is an optional membership here. No pressure at all. Think of it as a way to help keep these long, gentle, unhurried explorations coming. So there is always another story waiting when you need one. For now, there is nothing you need to do. You do not have to remember every detail or settle on any particular theory or solve the mystery of Rh-negative blood tonight. You can let it all settle. Let the images fade. Ancient fires, frozen valleys, silent laboratories, hospital rooms where a small vial of medicine turns a potentially lethal incompatibility into a healthy birth. Feel your own heartbeat, steady, patient, older than any legend. The blood that puzzled scientists. The blood that moved through empires. The blood that did not disappear when everything suggested it should have. It is all the same story, all the same river. And tonight, it carries you gently toward sleep. Rest well. May your thoughts be soft, and your body remember in its own quiet language that you are part of a line of survivors stretching back almost 1,000,000 years. Good night.